Okay, this section is going to look pretty similar to something we've done in the past. So we are going to do transformations. We've done transformations of quadratic functions and linears, and now we're going to apply it to exponential functions also. So here's the function we're going to work off of. So 2 to the x. That's considered kind of our parent function, just like when we were talking about parent functions with quadratics as well. So if we go from 2 to the x to this function right here, we're actually multiplying the entire function by negative. So if we were to rewrite that function, we would write it as -2 to the x power. And notice that instead of the function crossing at +1, it now crosses at -1 because of that negative out in front. And physically what happened is we took the graph, remember here's the original, and it reflected over the x-axis, which is the same thing that happened with quadratics, and it would go from facing up to facing down. So it is going to be reflected over the x-axis. So that's one type of transformation that we could see with exponentials. So here's another transformation. So we're taking our original, remember 2 to the x, and we are adding 3 inside the parentheses. So let's rewrite that function. So we're going to have f of x, and instead of 2 to the x, we're going to have 2 to the x plus 3 power. And this transformation is almost the same as with quadratics. If we were adding 3 inside the parentheses, that would be moving our graph to the left. So we're going to move 3 units to the left. And if you remember, we started at +1, but if we move to 3 units to the left, 1, 2, 3, over here is now +1. Here, if we were at 2, move over 1, 2, 3. Over here, we're at 2. So it took our original 2 to the x and shifted it to the left 3 units. All right, let's look at another transformation. So this is very similar. So instead of x plus 3 inside our parentheses to our independent variable, we're now subtracting 3. So if we rewrite this, f of x, instead of 2 to the x, we're going to have 2 to the x minus 3 power. So instead of shifting to the left 3, we're now going to shift our entire graph to the right 3 units. So again, if we started at our y-intercept of 1, 1, 2, 3 would put that 1 there. Here was 2, but if we move 1, 2, 3 over, so it took our entire graph and just shifted it to that right 3 units. All right, let's look at another one. So this one's similar, except that it is subtracting 3 outside the parentheses, and that's happening to our dependent variable or our y value. So if we're doing something outside the parentheses, it's going to either shift it up or down, or it's going to make it, remember, skinnier or wider. In this case, since we're doing f of x minus 3, it is going to be 2 to the x, which was our original, and then just subtract 3 on the outside of it. So it's going to, we started at -1, remember, on our, or sorry, +1 on our y-axis, and it moved it down 1, 2, 3 units. So it's going to shift down 3 units. All right, and then very similarly, if we add 3, the opposite thing happens. We're going to end up with our 2 to the x power plus 3, and that's going to shift the entire graph up 3 units. All right, so let's look at another one. Okay, so let's look at one. So this one is not multiplied by a negative, it's multiplied by a whole number, which is 3. So if you look at the graph, we want to first write the equation. So f of x, remember we're multiplying 2 to the x times 3. So it'll be 3 times 2 to the x. So that means instead of the graph crossing at 1, it's now crossing at 3. So what this is doing is this is now stretching this graph. It is going to stretch it vertically specifically by a factor of 3. And remember, at our 1, 2 was a point on the 2 to the x graph. Now it's 1, 6. So it's multiplying that y value by 3. So let's kind of sum up all of these ideas. So remember when we are adding or subtracting something outside of the parentheses. In this case, we're subtracting, so that's going to shift the graph down. Because we're assuming that that value is going to be something greater than 1, and that's what it says right there. If we're adding something inside the parentheses, remember that's going to shift the graph left, and the number of units would be whatever k is equal to. And then the last one, letter C, it's going to vertically stretch that graph, and then by whatever factor that k is. So we have minus outside the parentheses is down, add inside the parentheses would be left, shift or vertically stretch if that were being multiplied by a number greater than 1. Okay, so right now we have a function, g of x, and it's representing an exponential function. The ordered pair, 6, negative 3, lies on this graph. So we know that we have an x value of 6, and I'm going to make a little table over here, and a y value of negative 3. So what happens if we add 5 outside the parentheses? Remember, outside the parentheses is happening to our y value. So our x value is not changing. And if we add 5 to that negative 3, we're going to end up with 2. So 6 positive 2 is what's going to be outside, or our new point on this new function if we were to add 5 outside the parentheses. Now, I'm going to use this same table. So we have 6, negative 3. And now we're multiplying by 2 inside the parentheses. So our y value is not changing. What's changing is our x value. And you may want to put 12 here. But remember, if it's happening inside the parentheses, we want to do the opposite. The opposite of multiply by 2 would be divide by 2. So that 6 now becomes a 3. So 3, negative 3 would be our new value. And the reason why it's opposite is that we're trying to think about what value of x could we put up in there to get an output of 6. So 2 times what number gives us 6, and that would be that 3. All right, let's look at another question. So recall our original graph, 2 to the x. So which directions are we moving if we subtract 3 and add 2? So we're subtracting 3 inside the parentheses, so that's going to shift, and that's going to shift right 3. And that plus 2 outside the parentheses is going to shift it up 2. All right, so let's look at the following graph on the bottom. So it says f of x is a transformation of an exponential function. G of x is 2 to the x plus 1. So how are we getting from 2 to the x plus 1 to this new graph? So if we're starting at 1, and we want to get to this graph is actually crossing at negative 2. So how do we get from 1 all the way down to negative 2? We're going to subtract 1, 2, 3. So instead of 2 to the x plus 1, our new function is going to be 2 to the x minus 3, because we're taking that from 1, our original 2 to the x, and we're shifting it down 1, 2, 3. Good. Okay, let's look at the last question. This question is using the function 1/2 to the x power, and we want to decide what all of these things are doing to this 1/2 to the x. So if we're adding 2 inside the parentheses, that is going to shift our graph, and that's going to shift it specifically left 2 units. If we're subtracting 2 outside the parentheses, that's going to shift our graph down, and it's specifically going to shift it down 2 units. If we're multiplying it by negative 2, there's actually 2 things that are happening. Let's first talk about that negative. That negative is going to reflect it over the x-axis. And then multiplying it by that 2 is going to vertically stretch it by 2, or a factor of 2. Subtracting 4 inside the parentheses is going to shift our graph. It's going to shift it right, and it's going to shift it right 4 units. And then our last one is plus 3 outside the parentheses, and that's going to shift our graph up 3 units. All right. I hope that was clear. And again, if you have any questions, please message me on Reminder email. Bye, guys.